Have you ever heard of a ghost volcano? No, not a haunted mountain, but something far more colossal and mysterious. A supervolcano that has completely vanished from the face of the Earth. It sounds like something out of a science fiction movie, but this is a real geological puzzle that has scientists scrambling for answers. Today, we're diving deep into one of the most intriguing mysteries of our planet, the case of the missing supervolcano. So what exactly is a supervolcano? Forget your typical cone-shaped mountain. We're talking about geological giants, capable of eruptions so massive they can alter the global climate and change the course of life on Earth. Yellowstone is probably the most famous example, but it's just one of many that have shaped our world. These aren't just volcanoes. They are planetary-scale forces of nature. An eruption from one of these can spew thousands of cubic kilometers of ash and rock into the atmosphere, blocking out the sun and triggering a volcanic winter. They leave behind enormous craters called calderas, some stretching for tens of kilometers. These calderas are the telltale fingerprints of a supervolcano. But what happens when even that fingerprint disappears? That's the core of our mystery. Geologists have found evidence of unimaginably large eruptions in the geologic record, vast layers of ash and tuff spread across entire continents. By analyzing the chemical composition of this ash, they can trace it back to a single gigantic eruption. They can even date it. But when they go looking for the source, for the massive caldera that should be there, they find nothing. It's as if the scene of the crime has been wiped clean. How can a geological feature the size of a small country simply vanish? This question has sparked a fascinating debate and some truly mind-bending theories. One of the leading theories is that the evidence was, in a sense, eaten by the Earth itself. This is where the concept of plate tectonics comes into play. The Earth's crust is not a single solid shell. It's broken up into massive plates that are constantly, albeit slowly, moving. They drift apart, they collide, and sometimes, one plate slides beneath another in a process called subduction. Imagine a conveyor belt. Now, what if our supervolcano was located on a piece of oceanic crust that, over millions of years, was forced to dive under a continental plate? The entire caldera, along with all the direct evidence of the volcano, would be recycled back into the Earth's mantle, erased from the surface forever. All that would be left is the widespread ash, a ghostly reminder of the titanic eruption that once was. This subduction theory is compelling, and we have evidence of it happening. For instance, geologists studying ancient ash beds in North America have traced their origin to a source that should be somewhere in the Pacific Ocean, but there's no caldera there today. The most likely explanation is that the plate it was on has long since been subducted under the North American plate. It's a geological disappearing act on a grand scale, playing out over eons. It's like finding a bullet in a wall but discovering the entire building where the shot was fired has been demolished, and the land is now a park. You know it happened, but the source is gone. But subduction isn't the only possible explanation. Another idea is that some supervolcanoes are just exceptionally good at hiding. After an eruption, the empty magma chamber beneath the caldera can be refilled with new magma. This can push the caldera floor back up, a process known as resurgent doming. Over millions of years of further volcanic activity, erosion, and sedimentation, the original caldera could be buried, fragmented, or completely disguised by newer geological formations. It might not have vanished entirely, but instead it's wearing an incredibly effective camouflage. Finding it would be like searching for one specific brick in a city built of countless bricks, all jumbled together over time. To hunt for these hidden giants, scientists use some seriously advanced technology. They use seismic tomography, which is like giving the Earth a CT scan. By measuring how seismic waves from earthquakes travel through the crust, they can map out variations in rock density and temperature. This can reveal the ghosts of old magma chambers, the cold, solidified rock bodies that once fed a supervolcano. They also use high-precision gravimeters to detect subtle changes in gravity, which can indicate the presence of buried, dense volcanic structures. It's high-tech detective work, peering deep beneath the surface to find clues that were erased from view millions of years ago. One of the most famous examples of this search is the Whitsunday volcanic province in Australia. Around 130 million years ago, this region experienced volcanism on a scale that dwarfs almost anything we can imagine. The evidence is there in the form of vast volcanic rock formations. For a long time, scientists couldn't find the calderas that must have sourced these eruptions. But by combining gravity and magnetic data, they've recently identified what they believe are the buried remnants of these ancient supervolcanoes, hidden beneath the waves of the Coral Sea and layers of younger rock. The giants were there all along, just waiting to be found. So why does this all matter? Why spend so much time and effort hunting for volcanoes that are long dead? Well, understanding these vanished giants is crucial for several reasons. First, it helps us build a more complete picture of Earth's history. These eruptions were planet-altering events. They caused mass extinctions and dramatic climate shifts. By identifying them, we can better understand the cycles of life and death on our world. It's like finding a missing chapter in a history book. Without it, our understanding of the story is incomplete. Second, it helps us understand the life cycle of supervolcanoes. Are they a one-and-done deal, or can they reawaken? How do they form? How do they erupt? And how do they die? By studying their ancient remains, we can refine our models for present-day supervolcanoes, like Yellowstone. The more we learn about the past, the better we can understand the potential hazards of the future. While the chance of a super eruption in our lifetime is incredibly small, the consequences would be global. Therefore, any knowledge we can glean from these ancient ghosts is invaluable for our own planetary risk assessment. The mystery of the vanished supervolcano is a perfect example of how dynamic and ever-changing our planet is. The ground beneath our feet is not static. It's a world of constant creation and destruction. Mountains rise and fall, oceans open and close, and even the largest volcanoes can be erased from the map. It's a humbling reminder of the immense power of geological forces and the vast timescales over which they operate. It's a story written in stone, erased by time, and rediscovered by human curiosity. The search continues, and with every new discovery, we get one step closer to fully understanding the incredible and sometimes violent story of our home, planet Earth. Thanks for joining us on this geological detective story. It's a fascinating subject, isn't it? If you enjoyed this journey into Earth's mysterious past, be sure to hit that like button and subscribe to our channel for more deep dives into the wonders of our world. And let us know in the comments, what other geological mysteries would you like us to explore? Thanks for watching.